Let me go over Chapter P, Day 2 Notes. Uh, so let's just review some formulas here. To find slope, slope is simply the change in the y value divided by the change in x value. So as long as we have two ordered pairs, we can always find the slope. So here, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Rise over run, change in y over change in x. Linear equation, we can write it in point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. X sub 1 and y sub 1 represents the ordered pair. M is the slope. And we keep the y and the x variable when we write the equation. Slope-intercept form, y equals mx plus b. Y-intercept is b, m is the slope. Now, as we get into more types of problems where we have to write a lot of linear equations, I'm going to try and encourage students to try to use the point slope form. They're just a little bit more efficient and also less room for mistake rather than going to slope-intercept form. But both forms are fine, but I'm going to encourage students to do point slope form. Parallel lines. Parallel lines is when slopes of lines are equal to each other. So if we compare two slopes of two separate lines and they're equal, then we know that the two lines are parallel to each other. Perpendicular lines is where slopes of lines are opposite reciprocals of each other. For instance, if I have slope of a line being 1/3 and then the slope of the other line being a -3, then the fact that the two slopes are negative or opposite reciprocals of each other indicates that the two lines are perpendicular to each other. Vertical lines, if we want to write the equation for vertical lines, it's always x equals a constant. So for instance, x equals 3 will produce a vertical line through the x value of 3. Horizontal line always has y is equal to a constant. So horizontal line equation, y equals 5 would be represented by this line that's going through the intercept, y-intercept of 5. Okay. And finally, solving inequalities. So the steps for solving inequalities, let me go through those. First, we want to rewrite the inequality as an equation. So replace the less than or greater than inequality with an equal sign. Second step, we want to find the critical values by setting both the numerator and the denominator equal to 0. And next, make a sign line or make a number line or sign line using the critical values that we found from step B. And finally, we're going to test the values on the sign line using the inequality from the original inequality to determine where the intervals is true and where the intervals are false. Okay, so let's look at this example here. Solve x plus 3 over x plus 3, x plus 5 divided by x plus 3, which is less than x plus 1 over x minus 1. So first step, we're going to rewrite this as an equation. And I'm going to next bring everything over to one side of the equation, x plus 5 over x plus 3 minus x plus 1 over x minus 1 is equal to 0. Let's go ahead and get this to be one fraction by finding a common denominator being x plus 3 and x minus 1. So we're going to balance the two numerators. So x plus 5 times x minus 1 minus x plus 1 times x plus 3 all over our common denominator, x plus 3 times x minus 1. We're going to clean up the parentheses here by expanding. And once we expand, we can combine like terms. Everything will cancel out except for 5 minus 3, which is, negative 5 plus 3, which is a negative 2. And the denominator being x plus 3 over x minus 1. Okay. So now, once we have this, we're now going to find the critical values. Now, critical values is where we set the numerator equal to 0, and then separately, we're going to set the denominator equal to 0. So if we set the numerator, negative 2 equal to 0, that's not going to give us any solution, so we ignore that. the denominator, x plus 3 equals 0, x minus 1 equals 0, we'll get negative 3 and a positive 1. So now we're going to take those two critical values and we're going to put them on a sign line. Negative 3 and positive 1. So now we're going to test each interval with the original inequality. If I plug negative 4 in, I'll get 1 over negative 1. So negative 1 is going to be less than negative 3 over a negative 4, so 3/4. So negative 1 is less than 3/4. We know that's true. So I'm going to put a check mark there to indicate that this will be part of our solution. If I plug in 0, I'll get 5/3 is less than negative 1, and that is false. So we know that I put an X here to indicate that this cannot be part of the solution. And finally, I'm going to test a value that's to the right of 1. So I plug in 2, so 2 plus 5 over 2 plus 3. So 7 over 5, 7/5 is going to be less than 3 over 1. So 7/5 is less than 3. That's true. So now our two intervals will be from negative infinity to negative 3, and then from 1 to infinity. And again, these are going to be open circles because the inequality is less than, not less than or equal to. So that's our solution. Negative infinity to negative 3, union 1 to infinity.